connect the 24 volts power supply and Ethernet cable. Check the operating status of the board's indicator lights. If running normally, test the ping value. Check the network connection status. Press Win+R, then enter ping 192.6.6.6. Test the connection. If a timeout occurs, reconnect the Ethernet cable. Check the Ethernet cable connection. A reply indicates a successful Ethernet connection. Open the software installation package. Click to run QLMark EXX. When the software opens and this error appears, open this runtime to proceed with the installation. The installation typically defaults to all options. Proceed directly to the next step for installation. After installation, close the software. After installation is complete, restart the software. The software runs normally. Enter the user management interface. Set the administrator password to 1. Technician password to 2. Operator password to 3. Passwords can be modified as needed. If the board is not connected at this time, click No. Do not perform the homing operation. Select File. Open System Set. Choose Drilling. First, click Device Set and choose Card Set. Set the board communication parameters to 192.6.6.6. Then connect. This status indicates a successful connection. Change the mode to Mode 2. Set motor configuration. Assign the X, Y, and Z axis to the motor's 3 axes. Click Apply to save after each parameter modification. Click Motor Set. Set the card cord according to the motor manual. Set the work speed, limit speed, 0 speed, and manual speed. Note, axis 3 is the Z-axis speed. Because the Z-axis travel is shorter, the speed value should not be set too high. Check XYZ axis real-time data to confirm if the data are increased or decreased accordingly. If not, we need to reverse the encoder. Open MCCENV. Choose Motor and Motor Setting. Click Model Control Mode to be 1++ positive. Click Reverse. And apply. Change the motor number to be 2 and 3. If need, invert more axis. Click Reverse. Click Invert and apply. After modification, close the MCCENV. Manually test the movement direction of each axis. If the movement direction is opposite to the command direction, reverse the corresponding axis direction. After completing the settings, click Apply to save. Click Device Set. Set the cutting range to the platform's working range. Click Back 0. Begin the Back 0 operation. Test whether each axis operates normally. The machine's working status during Back 0 like this. Debug and test the X, Y, and Z axis separately. This indicates that the machine can operate normally according to correct commands. Select the laser type. Choose the corresponding laser type. For CO2 and fiber options, select Fiber. Check MOPA fiber and light leakage. Here, we use the fiber laser as an example for all subsequent demonstrations. Test the laser. Settings, laser power, frequency, Q pulse width. Hold time, frequency, and Q pulse width, set according to the laser machine manual. Adjust power and hold time based on test requirements. Prepare a black paper. Click Laser On. Check if the laser emits normally. If the black paper shows a laser spot, the laser is emitting normally. If the laser does not emit, check if the laser source wiring is correct or not. Use the laser source software to test if the laser emits normally. If the laser emits normally, based on the emission point, click Craft and open Drilling Set. Set the Z-axis start parameters. Click Correct and choose Galvo calibration. Set the test count to 1000 for marking. Adjust the Z-axis up and down to focus. Manually adjust the Z-axis to the appropriate focal length. The laser should be clearly visible on the glass, indicating the focal length is correctly set. The Z-axis coordinate is displayed at the bottom. Input the coordinate parameter to the starting position. Click Correct. Select Galvanometer calibration. Set the galvanometer marking range based on the lens parameters. If the maximum range is 100, enter 100. Use default settings for other parameters. Currently testing galvanometer 1. Prepare black paper for direction testing. Place it within the platform's working range. Click Direction Test. If the X or Y-axis direction is incorrect, compare the actual test results with the correct results. Adjust the X and Y-axis directions and positions. Click Direction Test again. Verify if the results are normal, after confirming the X and Y-axis directions. Proceed to the next step. Select a rectangle for test marking. Set the diameter to 20 mm. Other parameters remain default. Place black paper on the platform. Click Mark the resulting square size. If the size does not match the set value, in the subdivision ratio, manually enter the actual length. Click OK to auto-generate. After adjusting the subdivision parameters, trial mark again, until the trial marking matches the input value. If the trial marking square is distorted, enable advanced correction. Adjust parameters and mark again, until the marking square matches the correct size and shape. Laser on-off delay settings. Manually draw a rectangle, click Craft. Open the drilling settings. Select 2D flying for the processing mode. Open the flying parameter settings. Select Intelligent Fill mode for the flying mode. Select Bow path for the flying path. Set the spacing to 3 mm. Fill in other parameters as needed. After completing the settings, click Save. Click Start to begin marking. If the marking results are uneven, adjust the laser on-off delay. Open the drilling parameter settings. Observe the marking starting point for left or right offset. If the starting point is offset, increase the laser on delay parameter to delay the laser activation. If the endpoint is offset, increase the laser off delay to delay deactivation. After completing the settings, click Save, Retest until the marking aligns correctly. Click File greater than Open Vector File, then import your graphic or draw a simple graphic. Then align the layout. Click Craft and choose Drilling Setting. Select the processing mode set to D-Fly. For mirror paint removal, set the flying mode to Loops Fill. Set the spacing to 0.03 mm. Set the fly path to round. Click Get. Click Plan, then Save. This layer count determines the machine's working cycles. Start processing. Except for silver mirrors, other paints, for example, aluminum mirror paint, are harder to remove, requiring 2 working cycles. Adjust based on actual conditions. This is a sample after paint removal. Manually test the marking result or use a microscope.